Welcome back. This is All This Math. This is Professor Parker. Make sure you're subscribed to the All This Math YouTube channel. Make sure you drop a comment down below. Make sure you share this video with somebody. Make sure you like the video too while you're at it. Now, what are we doing today? Today, we are dealing with Keystone algebra examples. Now, the Keystone exam is a standardized test that is taken in the state of Pennsylvania by students in order to demonstrate their level of proficiency in Algebra 1 topics. All right. So this is an example of what one of the questions they might see on the exam may look like. Let's read it. It says, which expression is equivalent, that's an important word, equivalent to this fraction right here. This is a fraction. That's a fraction bar, right? No matter how complex it looks, at the end of the day, it's still a fraction. 2x squared minus 98 divided by or over x squared minus 14x plus 49, right? That's the fraction. When x, this symbol means is not equal to, when x is not equal to 7. Why is this part relevant? It's not really relevant for in terms of like how we're going to find the answer to this question. But what this means is that x can't be 7 because what would happen if x was 7? If x was 7, look what's going to happen. Like, we're not going to worry about if you plug in x in the numerator. We're going to worry about what happens if you plug in x in the denominator, the expression at the bottom of the fraction bar. 7 squared is 49. Negative 14 times 7 is negative 98. 49 minus 48, 49 minus 98 is negative 49. Negative 49 plus 49 equals 0. What happens when you have a 0 in your denominator? We don't do that because that's undefined, right? That's called undefined because we can't divide by 0 in the real number system. So in the real number system, we can't divide by 0. So therefore, we don't want 7 to be x because that's what that's going to cause. All right. Now, it doesn't matter what it's going to have in the numerator. You can have any number you want in the numerator. You just can't have 0 in your denominator. So that's why this part is here, right? It's really just like a formality. But what you should understand is that in a question like this when x does not equal 7 part is just meant to like throw you off, maybe even confuse you. It's really not relevant for what we're trying to do, right? You should understand it, right? As a person that's studying math, but you should understand why it's there, but understand for what we're about to do, it's not really that relevant. All right. Now, how would we simplify this, right? We're not solving it because we're not trying to find out the numerical value of x. That's not what we're doing. We want to simplify it because look at the choices. 2 times the quantity x plus 7. 1 over 7x. 2 times the quantity x minus 7 over x plus 7. 2 times the quantity x plus 7 over x minus 7. Right? These are 4 choices. Whenever you want to simplify expressions that look like this, always try to factor them out. Always try to factor them first. All right. Now, there's a bunch of different ways of factoring based on how the expression looks. This is a binomial, right? And so you should always look for a greatest common factor of your terms, first and foremost. Always look for a greatest common factor. It just so happens that in this numerator, the greatest common factor of 2 and negative 98 is 2. So we can factor out a 2. All right. So let's start factoring. So we're dealing with the numerator first, right? So the greatest common factor is 2. So therefore, we're going to write 2, and then we're going to write parentheses. And then inside the parentheses, we're going to put the quotient of the original terms divided by 2. Now, factoring out a GCF of algebraic expressions is a skill you must have in Algebra 1, right? If you've taken an Algebra 1 course and you don't know how to factor trinomials, binomials, four-term polynomials, you don't know all the different methods of factoring, you need to go revisit that coursework. All right. You have to know how to factor. And because in every course after that, you're going to have to know how to factor. Go to my playlist on factoring, right? Matter of fact, I got different playlists on factoring depending on the different type. All right. It's different types of factoring. I got different playlists for each type of factoring. All right. But factoring out a GCF is something that you must know how to do. So we're going to divide 2x squared by 2. 2x squared divided by 2, the 2's divide out, leaving you with just x squared as your quotient. So what do you do with the x squared? You write it inside the parentheses. Then you do the same thing with the negative 98. Don't forget that minus sign. That's not a positive 98. That's a negative 98. Negative 98 divided by 2 is negative 49. Negative 49. So you're going to put minus 49 down there. All right. Now, again, where'd the x squared come from? 2x squared divided by the GCF gives you x squared. You also got to know how to divide monomials. You got to know how to divide. That's something you got to know how to do when you get to this level. Where did negative 49 come from? Negative 98 divided by 2. Everything is a pattern. You find the GCF, you write it down. Then you divide everything by the GCF, which gives you this. All right? Then let's look at the denominator. We're actually not finished factoring this. This can be factored further. We're going to get to that in the next step. But let's look at the denominator. The denominator is a trinomial. Why is it a trinomial? Because the prefix tri means three. TRI, like a tricycle has three wheels. This has three terms. 1, 2, 3. Terms are separated by plus or minus signs. Plus or minus signs separate terms. Right? That's a minus sign. That's a plus sign. So this is a term. This is a term. The 14 with the x together is one term. All right, 49 is a term. This is a trinomial. It's also a quadratic. How do you know that? The biggest exponent you see is a 2. There is a specific way to factor or attempt to factor, because everything's not factorable, but many expressions are. There's a specific way to factor quadratic trinomials. One way is this. You first write two sets of parentheses. And you take this x squared and you break it down into x and x. So you're going to have an x right here and an x right here. Then you look for factors of the last number, the constant, that also add up to the coefficient of the middle term. Factors of the last number, the constant, that also add up to the coefficient of the middle term. So 49. Let's say you don't know all the factors of 49 by heart. Let's write them down. So let's say 49 and 1. And then, matter of fact, let's write them down here. Let's write them somewhere else. Let's say 49 and 1. And 7 times 7, factor pairs, right? I don't think 49 has any more factors than that. 49 and 1 and 7 and 7. That's it. That's all we got. Now, 49 and 1 I know doesn't add up to negative 14. 7 plus 7 doesn't add up to negative 14. But look, I got the right number with the wrong sign. Whenever that happens, change the signs. Isn't negative 7 times negative 7 also equal to positive 49? The rule is for this type of factoring, which you also must know how to do at this level, you must know how to factor quadratic trinomials, where your lead coefficient, I forgot that part, the lead coefficient is a 1, an invisible 1. When it's set up like this, all you need is the two factors of the last number that also, those same two numbers must also add up to the coefficient of the middle term. Negative 14x is the middle term. Negative 14 is the coefficient. The coefficient is the number that's connected to the variable. That's what that's what the coefficient is. All right. Negative 14. It tells you how many x's we have. We got negative 14 x's, which means we owe somebody 14 x's. That's what that means. All right. So the negative 7 and the negative 7. So you put minus 7 here and you put minus 7 here. All right. Now, then you start to look and see, can I cancel anything out? Some people don't like that term. Can I divide anything out? All right. I can't. Right. Now you cannot do x squared divided by this x. The reason you can't do that, some people will try to do that. That's wrong because x squared is part of this binomial, just like this x is part of this binomial. Binomial because there are two terms. 1, 2, binomial. 1, 2, binomial. 1, 2 over here, binomial. Now, we can't simplify anything, but again, we have to know how to factor in order to do this problem, because then you would recognize that x squared minus 49 can also be factored, right? This is called a difference of two squares. A difference of two squares. You got to know that, right? You got to recognize differences of two squares. That's the purpose of learning all that. So you'll be able to solve problems, all right, down the road. So the way you factor that is you're going to bring the 2 over. You write two sets of parentheses like such. Draw your fraction bar. Then you're going to have x minus 7 times x minus 7, right? We just copy this over, right? Now, you take the square root of each of these terms. The square root of x squared is just x. You're going to put x in the first space in both parentheses. Put the square root in the first space in both parentheses. It's like a game, right? Or a puzzle. You're just putting things where they belong. All right. Then you're going to take the square root of the second term. We're going to act like it's positive. We're not going to act like it's negative because technically negative 49 doesn't have a square root in the real number system. We're going to treat this like it's positive 49 temporarily. The square root of 49 is 7. That's something that you also must know. You must know that the square root of 49 is 7. So you're going to take the 7, you're going to put a 7 right there, you're going to put another 7 right here. Now, what signs are going to go in between? Like these have signs in between. What signs are going to go in between? You're going to make one plus sign and one minus sign. Does it matter where the plus or minus sign goes? No, it doesn't. It doesn't matter, right? I could have put the minus sign first and the plus sign second. Now you look to see if there's anything that can cancel out. And I noticed that I have an x minus 7 on top and an x minus 7 on the bottom. So those are going to cancel out and become ones, right? Because they're basically dividing something by itself, which equals 1, leaving you with 2 times x plus 7 over x minus 7, right? So then you go back, look at your answer choices. Which one is that? X plus 7 on top, x minus 7 on the bottom. All right. But in order to do a problem like this problem is not that deep. If you know how to factor, you must know how to factor. If you don't know how to factor, this problem and problems like it will be very difficult. You need to know how to factor out a greatest common factor from an algebraic expression, right? I got a whole playlist on how to do that, right, on this channel, which you should be subscribed to. You need to know how to factor a quadratic trinomial when the lead coefficient is 1, or we say when A, because A is the letter we use to represent the lead coefficient. When A is equal to 1, you need to know that method of factoring, and you need to know the dots method, differences of two squares, how to factor out a difference of two squares. I got a playlist on that too. So 3 types of factoring you need to be aware of in order to do a problem like this correctly. Then you need to know how to divide out expressions. All right. And you also need to remember that you can't do x squared divided by x because this x squared is part of a binomial. This x is part of a binomial, just like this x is part of a binomial. So it's 3 types of factoring that you need to know in one problem, right? But in Algebra 1, you need to know how to factor. You have to know how to factor. It's imperative. All right. So definitely practice with expressions like this, factoring out GCFs like we did in our first step, factoring the difference of two squares like we did right here from this to that, right? Factoring quadratic trinomials, right? When the lead coefficient is positive 1, right? You need to know that as well. All right. These are skills you have to know. This is a non-negotiable. You just got to know it. All right. So make sure you subscribe to the channel. Make sure you drop a comment down below. Make sure you like the video. Make sure you share the video with somebody. And I'll see you on the next video. Peace.